Welcome back. The objectives of this video, we will be asked to consider reference angles for any angle and determine coordinates of points on a circle centered at the origin. In this lesson, we will also consider angles that do not lie in quadrant 1 in order to determine exact function values for sine and cosine. I encourage you to have your unit circle handy if you don't have the first quadrant memorized, as we will be using things on the unit circle. Some of these examples will not be on the unit circle, but it'll be nice to have that handy. We'll also finish with a calculator problem, so you might want to have your calculator available as well. So in example 5, we're going to let theta be an angle in standard position with an ordered pair of x, y, a point on the terminal side theta. We're going to continue to use x squared plus y squared equals r squared, but we're going to use the square root form of that, where we square root both sides, so we know that r is equal to the square root of x squared plus y squared, and it can't be equal to 0. In fact, it's going to be greater than 0, because our r is always going to be positive. Example 5 says use the figure at right to name the basic trig functions in terms of x and y and r, where r is the radius of the circle. So we've got the semblance of a circle here going through point x and y, where r is equal to the square root of x squared plus y squared. Well, we know that the sine of theta equals y over r. We know that the cosine of theta equals x over r, and we know the tangent of theta is y over x. But if we multiply both sides by r, we can isolate y. We can say y is equal to r times the sine of theta. And this is going to be important for us because r is not always 1. When we use the unit circle, r was 1, and so we kind of blew this off. But now if we have radius that's not 1, this is going to be helpful in allowing us to find y. And we can do the same thing for cosine. Multiply both sides by r and isolate x, and we get x equals r cosine of theta. Now for tangent of theta, that's y over x. That also is going to equal the slope of our line. So tangent is slope. But these two, y equals r sine of theta and x equals r cosine of theta, memorizing those is going to be helpful in our future math studies. In example 6, we're given an angle measure of theta is 4 pi over 3 in standard position in a circle with a radius of 5. So we know our r value is 5. And we're centered at the origin. Find the coordinates of x and y of the angle where the terminal ray intersects the circle. Well, our theta here is 4 pi over 3. Well, we should know that 4 pi over 3 is on the unit circle. Well, it's actually a pi over 3 reference angle in the third quadrant. Remember, location, location, location is important for us. Well, from our unit circle, it's likely that we have memorized that that's 1/2 square root of 3 over 2, but both of those guys are negative. So the cosine is negative 1/2, and the sine is negative square root of 3 over 2. Well, we can find, we've actually already found, we haven't found our x and y because we've got this radius of 5. Now these values are for a radius of 1 from our unit circle, and we've got a radius of 5. So let's take a look. We know that x equals r cosine of theta. Well, our r is 5, so x equals 5, and our cosine of our theta is negative 1/2. So x is equal to negative 5/2. And y is equal to r sine of theta, and y is equal to 5, and then the sine of theta is negative square root of 3 over 2. We snagged that from our unit circle, So y is equal to negative 5 times the square root of 3 over 2. So the ordered pair on a circle with a radius of 5 is negative 5 halves, and negative 5 square root of 3 over 2, or 5 times bigger or longer or further out than our unit circle values. In example 7, we're given theta terminates in quadrant 2. So that's going to be important for us. That tells us that our x's are going to be negative and our y's are going to be positive. And the cosine of theta equals negative 1 over the square root of 3. So we know that our r is 3 because cosine is x over r. So our x value is negative 1. Our r value is 3. So we can do the Pythagorean theorem to find our y value, and then we can find the sine of theta. So we know that x squared plus y squared equals r squared. So y squared equals 9 minus 1. So y squared equals 8. And y equals the square root of 8, or 2 square root of 2. And that's going to be a positive 2 square root of 2. Our x value is negative 1. We can find all of our trig functions. We're just asked to find the sine of theta. So the sine of theta equals the square root of 2 over 2 all over 3. It's y over r. In example 8, we're asked to find all the values between 0 and 2 pi. So that is essentially one loop of the unit circle, or between 0 and 360 degrees. But I'd like you to think of one loop of the unit circle where our cosine of theta is 0. So cosine is x. So where are our x's equal to 0? Well, if we think about our coordinate plane, x is equal to 0 in two locations. At pi over 2, where we have 0, 1, and negative pi over 2, or I can't use negative pi over 2, but 3 pi over 2, where we've got 0, negative 1. I can't use negative pi over 2 because I'm constrained between 0 and 2 pi. So all of the values are at pi over 2 and 3 pi over 2 are the two locations. Probably should use that word and instead of the plus sign. In example 9, if tangent of theta is 4/3, so tangent is y over x. So we know our y value is 4 and our x value is 3. And the cosine of theta is less than 0. So cosine is negative. Well, cosine is negative. X's are negative in quadrants 2 and 3. So this tells us we're working in either quadrant 2 or quadrant 3. But tangent is positive. So the only possibility is we have to be working in quadrant 3, where both cosine and sine, or x and y, are both negative. So we know x is going to be negative, y has to be negative. So a negative 3 and negative 4, that's our y over our x's. And now we need to find our radius r. We're in the third quadrant, where x is negative 3, y is negative 4. Oh, we love this. We remember our Pythagorean triples. This is a 3, 4, 5 right triangle. So we know by doing the Pythagorean theorem in our head that r is positive 5. And now we can find all our trig functions. Go back and read the question. Find sine and cosine of theta and the coordinates where the terminal side of the angle intersects the circle. So we want to find those ordered pairs. So our ordered pair is -3, -4. We found that. And if we want to find the sine and cosine, so sine of theta is y over r, so -4 over 5, and the cosine of theta is x over y, or x over r, so -3 over 5. In example 10, looks like we're going to be using our calculator here, so make sure you grab that out. A machine shop needs to drill through a steel plate at point P. Calculate the actual measurement for the placement of the hole, then use your calculator to approximate the location of the hole to be drilled. So we've got an angle of 25 degrees and we've got a radius of 14. So we want to find that using our trig. We want to find both x and y. Well, we know that x is equal to r cosine of theta, and y is equal to r sine of theta. Our radius is 14, so x is equal to 14 cosine, and our theta is 25. So, and our y value is also r 14 sine of 25. Well, 25 degrees is not on our unit circle, so we're going to have to use our calculator to do our trig function. So let's hop over to our calculator and make sure it's in degree mode and get this going. So I have my graphing calculator out, and if I look on my top menu here, I see that I'm in radian mode, but my question is working in degrees. I've got 25 degrees, so I'm going to have to change the mode. So I hit the mode key next to the second key, and you can see down a couple of notches here we have radian and degree, so I'm going to cursor over to degree, select that, and quit. And now my calculator is in degree mode. I've got my sine, my cosine, and my tangent function buttons here, and I just need to put this into my calculator. I need 14 cosine of 25. I hit enter, and I get 12.6888 for my x coordinate. And I can repeat the process for sine, 14 sine, my angle is 25, and I get 5.9167 for that one. So let's go back and answer our question. So stealing the values from our calculator, I see x is 12.688, round to the nearest thousandth for AP, and y equals 5.917, and our ordered pair for point P is 12.688 and 5.917, which will give us the approximate location of where to drill the hole for our machine shop. And that wraps up this lesson in trigonometry and finding x and y values given our trig functions. And we'll get some more practice with this when I see you in class.